Hi everyone. So we'll study our next topic, which is your rate of reaction. We are already studying this in the last video. What did we study? How do we find the rate of reaction? Like if you have a reaction of 2A plus B is giving you 3C. How will you write the rate of reaction? Rate of reaction will be equal to your delta A by delta T, and 1 by 2, 2 will become 2 will come in like in the denominator with the minus sign, because it's a reactant. Reactant's concentration is decreasing in the reaction. That's why here we are writing minus 1 by 2 delta A by delta T. Then minus of delta B by delta T, and here delta C by delta T 1 by 3 and with a positive sign. Why with a positive sign? Because product's concentration is increasing with time. Okay, so this is just a quick revision. Now we'll just do some questions based on this. The question tells you N2 plus 3H2. So they have given us a reaction, right? 3H2 is giving you 2NH3. This is the reaction. Now what does the reaction tells you? During the formation of ammonia, during the formation of ammonia, 2 moles of nitrogen disappears in 1 minute. In how much minute? 1 minute. 1 minute, yeah. So what we need to find? We need to find three things. We need to find firstly the rate of reaction. Second thing which we need to find is rate of appearance of NH3. So this we have already studied in the previous video. How do we find the rate of appearance and rate of disappearance? Third thing which you need to find is rate of disappearance of H2. And what is given to us is the volume of vessel is 1 liter. So let's do this question. So they are telling us 2 moles of N2 disappears. 2 moles of N2 is disappearing, right? Now, if I take it in this fashion, like how do I find rate of reaction? Rate of reaction will be delta N2 by delta T, right? In minus sign. Correct. What is delta N2 here? Concentration of N2, right? What is concentration? Moles per liter. So if I do moles per liter here, 2 moles by 1. And what is the time? Time is given to us 1 minute. We need to convert it into seconds. 1 into 60 seconds. So this will be equal to minus 2 by 60, which is equal to minus 1 by 60. So your rate of reaction is minus 1 by 60 moles per liter second inverse. This is your rate of reaction. Minus 1 by 30, right? Minus 1 by 30. So rate of reaction has come out to be 1 minute. This one will become minus of minus 2 moles, right? Yeah, because this side you have minus 1 by 1. 2 moles are disappearing. Minus of minus 2 by 60. So this one will become plus 1 by 30, right? 1 minute. Let me check. During the formation, 2 moles. Yeah, here is the hint. 2 moles of N2 is disappearing, right? So 2 moles of N2 disappearing means minus of 2 by 1 divided by 60, which is equal to your plus 1 by 30. Then what do you need to find? The second part tells you to find the rate of appearance of NH3. What will be the rate of appearance of NH3? Rate of appearance will be delta NH3 by delta T's mod, right? That is your rate of appearance of NH3. Now, how do we find the rate of appearance? Now, just write like this. You know, rate of appearance will be equal to your minus delta N2 by delta T, which is equal to a minus 1 by 3 delta H2 by delta T, which is equal to your plus of 1 by 2 delta NH3 by delta T. Now something is connected here, right? Like this thing we need to find along, and this thing is already known to us, correct? So just equate these both. When you equate these both, what will you be getting? Plus 1 by 30 will be equal to your 1 by 2 delta NH3 by delta T. Just cross multiply it, you will get 2 by 30 is equal to your delta NH3 by delta T, and which will be equal to 1 by 15. 1 by 15 will be equal to your rate of appearance of NH3. Then the third part tells you you have to find the rate of disappearance of H2. Rate of disappearance of H2. Same things you need to connect. So you can connect minus 1 by 30 equals to minus of 1 by 3 delta H2 by delta T, which will be equal to minus minus will, sorry, this will be plus. So minus 1 by 10 equal to, I think minus 1 by 10 will be equal to delta H2 by delta T. Now since there are no signs, we'll just ignore the sign and we'll just write 1 by 10 equals to delta H2 by delta T. Yeah. Okay. Next question, similar kind of question is there. So what are they telling us to do? They've given us the similar equation. 2N2O5 is giving you 4NO2 plus O2, and they are telling us if rate of appearance of NO2, what is given? Rate of appearance of NO2 is 2 moles per liter per second. What do you need to find? You need to find your rate of reaction, and you need to find your rate of disappearance of N2O5. Okay, just write the reaction for now. How do you write the rate of reactions? Rate of reactions will be equal to your delta N2O5 by delta T, and minus half here will be equal to your delta NO2 by delta T minus 1 by 4 here, and delta O2 by delta T. This is how you write the rate of the reaction. What is given to us? The rate of appearance of NO2. What value is given to us? Given value is the rate of appearance of NO2. What does it mean? Delta N2O5 by delta T is its mod is given to us as 2 moles per liter per second. Guys, please wait for 1 minute. Okay. Yeah. So this is given to us as 2 moles per liter second inverse, right? Just substitute, this thing is given to us, right? Just substitute it here. So your rate of reaction will be equal to your minus 1 by 2 into your rate of appearance will be rate of appearance of NO2 is given. 1 minute, I just wrote N2O5 instead of NO2. Delta of your NO2 is given. I mean, this value is given to us, right? So just substitute it here. Minus 1 by 4 into 2. So this one will become rate of appearance is there, right? So this one will be plus. So this rate of reaction will become 2 moles, sorry, 1 by 2 moles per liter second inverse. Okay. So this is the first answer. Second one tells you to find the rate of disappearance of N2O5. What is the rate of disappearance? Minus of 1 by 2 N2O5 by delta T will be equal to your 1 by 2, right? So what one will be this? N2O5 by delta T will be equal to your 1 by 2 multiplied by 2, which is equal to your 1 mole liter inverse second inverse. Okay, so this is how you find the average rate of the reactions. Just write the coefficient in the denominator, concentration by time, minus for reactants and plus for products. Second thing which we need to study is your instantaneous rate. Second thing which we need to study is your instantaneous rate. Same thing only, but instead of delta we are just writing D. Instantaneous rate is for very small delta T. Instantaneous rate is for very small delta T, very small time interval. Like for example, if you have a reaction 2A plus 3B is giving you 4C. You have to write the same things only. Instead of delta, you just need to write dA. dA by dt. dA by dt. Okay, I'll just write it again. dA by dt minus half, which is equal to your dB by dt minus 1 by 3, which is equal to your dC by dt plus 1 by 4. Same thing only. And how do you write the graphical representation? The graphical representation will look something like this. I am drawing two graphs, one for reactant and one for product. Sorry, reactant by time, and here I'll do reactant, let me draw it in a different slide. Graphical representation. Graphical representation will look something like this. You have a graph, two graphs I'll be drawing, one of reactant and one of product with respect to time. This is my reactant by time and this is my product by time. Okay, now you know, like with time your concentration of reactant is decreasing, right? The concentration of reactant is decreasing with time and your concentration of product is increasing. It was 0 in the starting, right? and it increases with time. Now, how do you find the concentrations actually? By slope. Draw a slope here. Draw a slope here. Now, there are two angles, right? Here you have an angle and here you have an angle. Always remember, just always take positive theta. Always take positive theta. Now, how will you find which is positive theta? Take your, like, I'll just tell you a trick how to find it. Math students can easily do it, but how will you actually find it? Take your hand, wherever you have your line, like this blue line, just place your hand like this. The upper part of hand, if it's in the upper part of the hand, that thing will be positive, and lower part of the hand will be negative. So upper part of the hand, whatever angle the upper part is forming, that one will be positive. So means you'll be taking this theta. So your slope will be equal to tan theta. And what is your tan theta? dr by dt. Change in y-axis divided by change in x-axis. dr by dt. Now similarly, if you draw the slope for product side, the product side, I'm drawing a slope like this. This is here, right? I cannot make an angle anywhere with this axis. I need to make it with an x-axis only. So I need to extend this thing. This theta is going to come here, and your slope will be equal to tan theta, which is equal to your dp by dt. Change in y-axis upon change in x-axis, that is your tan theta. Okay. So I think in next slides we will do more questions regarding this, as well as we'll be doing your factors affecting rate of reaction. So I hope everything is clear in this. We'll again revise it in the next slide. Thank you so much.